Okay, so today we're talking about symmetries of quadrilaterals. So some of you have seen this before. First and second period have, eighth you have not, but I know this was over spring break, that was a while ago. So this is kind of review to jump us back into math since we haven't thought about it in a while. So quadrilaterals, remember, are four-sided shapes that have straight sides, okay? So four-sided shapes, and there are some types of quadrilaterals that are really familiar, like rectangles and squares and parallelograms and rhombuses, trapezoids, okay? Those are all types of quadrilaterals which we'll be looking at specifically today. So if we jump ahead here, okay, so we're going to be looking at three things. We're going to be looking at lines of symmetry. So this is a line of reflection that happens to be on the figure that makes it fold onto itself. So if you can see, that heart there has got a line of symmetry right in half. If you were to fold that heart in half, those sides would match. Okay. If we look at rotational symmetry, this one's a little bit harder to grasp, but if we take a figure and we rotate it on itself, it will land on top of itself. It'll match perfectly. So when we look at notice the star right here, we've got this dot. If I rotate it and just so this dot lands here, now notice the one here is going to go up, this one's going to go over, and this one's going to go over. But essentially the star will look the same. We now just have a point that was on the side that's now at the top. So that is an example of rotational symmetry. Lastly, we have diagonals, and this is when we connect two non-adjacent, which adjacent means next to, so non means not next to, and then vertices or corners. So as you can see, I've drawn a pentagon. That's a five-sided shape, and these are all diagonals. So essentially they connect, these two vertices are next to each other, so we're going to connect this line and this line because now there's that dot in between, so they're not next to each other anymore. So we could even look at if we did, say, a four-sided shape of some kind. Okay, diagonals might just go across from corner to corner, just like that. So those would be diagonals in a quadrilateral. Okay, so if you have not written this down, hopefully you have your math notebooks with you or a place where you can take notes. I would write down these definitions, so it's really important that we have an idea of what these are about. So you can go ahead and pause if you need to. If you've already heard this before and you just need a review, we're going to jump in and do a little bit of a review. Okay, so all of you should have this, okay? And it does give the definitions here, but maybe you kind of want to add to it. Okay. So every time, the whole purpose of this is to experiment. So I need you to be using your patty paper on every single shape. So what we're going to do is try and find these symmetries that we just learned about. So first we've got our rectangle, and we're trying to find reflectional symmetry. That's this column here. Okay. So here's our rectangle. I'm going to try and find some lines of symmetry. So my initial thought is to just go across the way. So I'm going to try and get those vertices there to land on top of each other. Okay, so my rectangle's not perfect, but you see if I line those up, how they work out. Those corners kind of fold and land on top of each other there. So this figure lands right on top of itself, and I can see that with my patty paper. So I'm going to go ahead and put that on my paper. So there's a line of symmetry, and I've tested it. I know it from looking at this. Then I'm going to go ahead and do that same thing with maybe the other side, and notice again those corners right across from each other, and they just fold quite nicely right on top of each other. So again, by experiment with the patty paper, I know that this is a line of reflectional symmetry. Now I'm going to try maybe going from across this way. So if I maybe do a line going that way, notice, okay, ooh, that wasn't a very good line. Okay, so do you see how now this corner did not land on that corner like they did previously? It's pretty far off there. So that tells me that this is not a line of symmetry, and I'm assuming this way is not either. So I'm just going to kind of leave it be. So I think that those are my only two, and I'm going to say that I have two lines of symmetry. Okay? Then we're going to go ahead and do that same thing. We're going to just try it again. I want all of this experimentation to be seen with your patty paper. That's going to be the power of this activity. So here we go. We're going to try it again. And I'm thinking, okay, that worked. This looks a little different, but maybe try and go down the middle somehow. I'm not really sure where the middle is. Maybe right there. You see how my parallelogram did not land on top of itself. Okay. So that way's not. Maybe if I try this way. So I can get those sides to line up there, but you see how these corners aren't really right across from each other. This one kind of goes a little diagonal, and notice it doesn't go perpendicularly across, which I think had something to do with the rectangle. So that wasn't a line of symmetry. Okay, so let's try some diagonals here. So notice, again, this corner, those corners should have landed on top of each other, and they didn't. So that's not a line of symmetry, but it looks different the other way. So again, I'm going to try and fold along those corners. And look at that. I mean, now these right here are not even close. So again, those corners aren't going to land on top of each other. So I actually think there are no lines of symmetry for a parallelogram. So I want you to do this same thing, do this trial and error, and try and just see. There's just, oh, I think it might be this, I think it might be this. Try it out, and if it is, great. Draw it on your paper, and if it's not, no shame, right? So I want you to try those with all of the figures. So I would be going ahead and tracing all of these onto my patty paper so that I could experiment with the patty paper. Here. Okay, so you're going to do that same thing for the rhombus, the square, and the trapezoid, trying to find those lines of symmetry through using your patty paper. So once you go ahead and finish that, I would pause the video, but once you finish, you're going to want to go to rotational symmetry. So let's give a couple examples of what this might look like. So we're going to go ahead and take this. Rotational symmetry is going to rotate the figure. I'm thinking maybe somewhere on the center. If we did somewhere, we could maybe go around 360 degrees. Let's see if I can do that here. And we've landed exactly on myself, and I could even maybe do one over here. Excuse me. So notice I went all the way around this point, and I still landed. So we're looking for something other than 360 degrees. So, but maybe in the middle here, let's try and go 90. So that's going to mean this horizontal line became vertical. So we're going to go like so. So notice here, this line, now I'm more up and down than left to right. So 90 degrees didn't cut it. So I'm going to try going another 90. Now I'm back to being horizontal again. Notice how I've now landed on top of myself. So all the corners are matching up, all the side lengths are matching up. So that's rotational symmetry. So I'm going to put my center in here. And my angle measure was 180 degrees. Okay, so that made it work out. And I think if I went another 180, which would give me 360 in total, then that would land me back on top of itself. So we can add 360 here. Okay, and we're going to try again. All of this, we need to be using our patty paper. So we're going to go here. I'm thinking in the middle again. If I go 90, I didn't land on top of my figure. But if I go another 90, notice how I've landed on top of myself. Now my sides have matched up again. So again, I'm going to go here and say that's the center and say, okay, if I go 180 degrees, it's going to work out. And we can even try, right, 360 would get us right there. That would be 360 degrees. So 360 degrees would work as well. Okay, so you're going to want to follow that same thing using your patty paper. Try and find those here. Now, diagonals, those non-adjacent vertices in quadrilaterals, are actually just opposite corners here. So I'm going to go ahead and draw those diagonals in there. Now notice, as you do this, I want you to notice, look at our lines of symmetry here. Notice how they are not the diagonals. So that's interesting to note. Okay, so again, if we look here, and obviously these are not lines of symmetry because there are none for the parallelogram. So again, we can go through and draw all of our things and see, once we figure this out, are those lines of symmetry. So maybe are the diagonals the same or not the same as lines of symmetry. So that's a connection I want you to make, and you'll see on your homework that you're going to be asked to kind of describe times when a shape has diagonals be the lines of symmetry. So go ahead and finish this. If you have your notebook, go ahead and glue it in. If not, keep it in a place safe so that you have it for reference. Okay?